Hello there, and welcome back to another lesson in math. Today we're on Unit 1, Lesson 2. Our goal for today is to learn how to be more precise when we describe the moves of a figure. Yesterday we talked about sliding or moving things up and down, left and right. We also talked about turning things. Sometimes the sliding we referred to it as translate, and the turning we referred to as rotate. Today we're going to spend a little bit more time using that precise language to improve our description of how a figure moves about a plane. Remembering that a plane, this may be new vocabulary to you, a plane is simply a flat surface. So to begin, let's start with a piece that will help us out as we do this to make sure that we're more exact. I'd like for you to take a minute and estimate the angle of rotation. When we're talking about the angle of rotation, we're talking about how did this figure right here, the slide or figure A, end up onto figure B. One thing that might help us is to see that on a traced piece of paper so we can understand a little bit more how that would work. So let me go ahead and quickly trace this. And remember yesterday we talked about that these turning, when it turns, it has to be about a certain point or a center of rotation. So here's our center. The question is, how many degrees does it take to rotate the figure from here to here? Please pause the video and make an estimate of how many degrees this rotation is. All right, I hope that you paused the video and you took a minute to do that. Sorry, I keep bouncing all over the place. The question might be, well, Mr. Quilter, I didn't know exactly how to set this up, or I didn't really know what to look for when I did it. So I have a little strategy. The lot of lines here can be kind of confusing. So what if we eliminated some? Before we do that, let's pick 2 points that correspond or sit in the same point on the figure. On B, we're using, or excuse me, on A, we're going to use this point right here. And we can see that when we rotate, the corresponding point or the same point on the figure is this one here. So let's look at these two. And the question is, do I want to rotate this way counterclockwise, or do I want to rotate this way clockwise? We can see for efficiency's sake that it is shorter to rotate from here to here. But the question is, how can I figure out that exact measure? Well, it might be helpful to look at it with fewer lines. If I cover these up, and then hopefully you can see the line that's here and here. How would you, or what would you estimate that angle to be? Go ahead and take a look at your estimate and then revise it if necessary. And now we take a look. I think the easiest way to do that would be to use a protractor. But to make an estimate, clearly we can see that it's greater than 90 degrees. This yellow paper actually really helps us because this corner right here is 90 degrees. So we know it's a little bit greater than 90 degrees. And we have a good estimate. We could probably say it's not more than 130 or 140 degrees. When we set the protractor on here, we want to line it up to where this is the center. Follow the line out to 0, and then we can take an estimate on, in this case, on the inside, because that's where the numbers are increasing, and we see that this angle is approximately 120 degrees. There's a quick little lesson on using a protractor, a quick little review. What we need to get from this is that we need to understand the direction of the rotation makes a difference. In this case, we want to review quickly of what kind of rotation this is. Rather than saying left and right, we want to talk about clockwise and counterclockwise. For the purposes of this lesson, I will be abbreviating clockwise as CW and counterclockwise as CCW. When we talk about clockwise, we talk about a clock. And I'm only going to write 12, 3, 6, and 9 o'clock. And we talk about following a clock around in its normal rotation. When we talk about clockwise, we're simply referring to going in its opposite rotation. This will be important when we describe the way that things turn about an axis. With that in mind, let's use our new tools that we have, and our new understanding of these pieces, and let's go ahead and improve the way that we describe the way that figures move. To do this, I'm actually going to introduce a few new, or I'm going to talk about yesterday, and then I'm going to introduce some new vocabulary. Yesterday, we talked about moving for this shape, that it would move if it was in this plane and it came to this plane, that this figure from the left side of the box to the right side of the box would just be slide right. We see a new move right in here. We'll come back to that one. But we see that it kind of changed. Something in here happened with it that we're going to, for right now, we're just going to say new move. We'll come back to that one. We see on the next figure, it almost looks like from 3 to 4, let's call this maybe a little bird. It looked like it kind of just went like this and fell over to this one. So we can see from 3 to 4 that there was a rotation or a turn of 90 degrees. And then we see 5. It appears that from here it moved up. And 6, we see that same new move again. So let's talk about those moves. Let's use our new vocabulary with this to improve the way that we share exactly how things go. I'd like to jump over to the summary so we can talk about the vocabulary. In this case, we talk about translation, and we see this keyword. So translation correlates directly with slides. It slides a figure without turning it. This means that every single point on there is following the same distance, the same direction as we see right here. From going from figure A to figure B, this point to this point follows along this directed segment. That directed segment, just for the sake of vocabulary, you're going to hear it sometime, is called a vector. It's not something that we usually introduce, but there you go. We see that this one is traveling at this angle for this distance, and we see that this distance and those other ones appear to be the same. A quick measurement follows this to recognize that that's about 2.5 centimeters, 2.5 centimeters, and 2.5 centimeters. Translations never ever turn or rotate. A rotation is when a figure turns about a point. This is really important right here. That point right here is called the center of rotation. Every single point on the figure is going to follow around that circle exactly the same way and with the exact same distance. I'd like for you to think for a moment about the great big sprinklers that show up out in the fields. Actually, I'm just going to show that to you. Check this out. I think this is a really neat real-life example of rotation. When we think about Moses Lake and we see a map and we're just like, oh, okay, I can get from point to point. But I think something that's quite beautiful about it is when you go to the satellite view and we see a whole bunch of farms around, and you'll notice that all those farms have these, not all of them, but many of these farms have circular sprinklers in them. And we get this perfect sprinkler. In these pictures right here, we can see that there's a center right here. There's a dot right in the middle. As we zoom into it, we start to see other lines that are appearing. And these lines, I think, are great for an understanding of what rotation looks like, because sitting right here, there's actually a tower that has a couple of wheels. And that tower has motors on it, same thing out with all these other ones that drive around the field. But since they're connected to the center of rotation, they can never get any farther away or closer. So the distance from this center to this point never ever changes. It will always remain the same. Again, just to reiterate, this distance from here, oh, here we go, trying to make straight lines again, from here to here will never ever get longer or shorter. Pretend that's a straight line for me. This distance is always connected to what's called the center of rotation. I hope that offers just a little bit of a real life scenario of how rotation fits into our lives, where a rotation turns a figure about a plane and allows us, or about a point, and allows us to keep the center of rotation, and every point, or each of those towers, goes in a circle around that center and makes the same angle. For a brief example, that would always be followed in just one like this. We could see that figure A rotates onto figure C when it's going this way, which, referring back to this, is clockwise. Going the other way would be counterclockwise. It's important to recognize that we have a measure, an angle of measure, and for what we talked about with the center of rotation, let's give that a center point and go ahead and give it a name. The new move right here is reflection. We haven't talked about that one, but when we talk about a reflection, I want you to think about a mirror. If you're standing at a mirror and you step closer to it, your reflection appears to also come to you the exact same distance. Think about the mirror as this line right in the middle. This line is called a reflection line or a line of reflection. This line is necessary because this line is a bisector, or a line that is exactly halfway between every single point on every single corresponding point on each of these figures. So if I were to put a point right here, the corresponding location is right here, and the distance between those 2 points is going to be exactly halfway. So if we look at this piece and we see that it's looks like 1.5, 0.5, 0.6, 0.7, about 1.6 millimeters. And so we should be about 0.8, right between, it looks like it's about 17 millimeters actually. So that would give us about 8.5 millimeters on either side. And we see there's 5, 6, 7, 8 millimeters there. I'm sorry that's kind of hard, but we should be able to see that this is perpendicular, 90 degrees, and it bisects or cut those two in half. The reason I bring this up is because if it didn't, if one image was closer than the other, this would not be a mirror image. It would indicate that a reflection has taken place and a translation has also taken place. In this case, that reflection shows us where the mirror, or excuse me, this line of reflection shows us where the mirror should stand, and these distances should be the exact same distance apart for each of the corresponding points. The final words that I'm going to refer to again are image. Sometimes that we use this word to describe the new figure or the copy. So whatever was moved, that was created by moving the figure. If one of the points of the original figure moves to another point on the new figure, we call that a corresponding point. The point is in the same location, or the points are located in the same position on each figure. Why don't you go ahead and pause for a minute, take a break, stand up, stretch your legs, and then come right back to me. Okay, now that you've had a minute to take a break, let's go back and look at this. And I'm actually going to use a different colored pen. To describe how we made those moves. We talked at the beginning about how this was a slide right. What we should be able to do today is actually discuss frame 1 to frame 2 in a more precise way. Rather than saying slide right, we would say translate right. When we talk about from slide 2 to slide 3, we had that new move, which we now understand as a reflection. Those reflections, what we have to understand is recognize that this reflection line or line of reflection, this is a vertical line. So it's reflecting across a vertical line of reflection. That would be a good thing to recognize, and we'll learn more about that. When you get to 8th grade, the emphasis is on reflecting across the y-axis and reflecting across the x-axis. And so those will be the two axes that we see reflections on when we see these on a coordinate plane. We see the figure. We talked about how this one took it like this. Like if my thumb is this little point, we saw that it rotated, or that turn is now we understand it as rotation, and we see that it rotated clockwise, following the clock. We see that it turned over on its face, so we said clockwise. And in this case, we're going to up the game just a little bit and give it an angle measure of what appears to be 90 degrees. From there, from 4 to 5, we see that the figure went from right here and just moved up. Instead of saying moving up, we say translate up. And then the final thing, we saw that move again. If that figure is right here, crude little sketch, we see that new move, we learned that as a reflection. And so we would see that reflection over instead of vertical line, this is what we call a horizontal line, over a horizontal line. Okay. You'll notice that the difference between the two is this is not the same word. They do mean the same thing, but this is getting more precise in our language to describe the moves on the plane. Please make sure that you keep track of these pages. My strategy that I want to share with you is this. It takes a lot of work to write down a whole bunch of notes. On these pages, if you can get those pages in there and mark the text, it's going to be a little bit quicker. As you're writing those down, since you don't have these packets, you have the opportunity, you can either print it, or what I would suggest is when you write these down into your spiral notebook, just write the word translation and put slides next to it, either in parentheses or in quotations, and then without turning it. This would be your keyword. This underlined portion would be your definition. Again, rotation, keyword, definition. Turns about a point called the center of rotation. Clockwise, I would just write the word and draw a picture like what I did here. Same thing with counterclockwise. Reflection, I didn't mark the text there, but a reflection places points opposite sides of a reflection line. And you might grab some more details in here like mirror image. This would be something that I would quote for something to help me remember that it's backwards copy of the original. Reflection line is the mirror, shows where the mirror stands. Finally, image, I would say image, the definition is new figure or a copy. Corresponding points are located in the same position on the figure. Let's just recap real quick. I'm going to go ahead and skip this one. Let's talk about the cool down real quick. What type of a move takes figure A to figure B? Explain your reasoning. Please take a moment to write down a couple of thoughts and decide what it's going to take to get from point A to point B. All right, now that you've had a minute to think about it, hopefully you paused and you took some time to write it down. I'd like for you to recognize a couple of things. First off, we see that the images, there's two images. They appear to be exactly the same image, but we have to ask ourselves a question. I believe that I see a rotation right here that takes the figure from here to here, and I want to show you another little strategy. I like to go like this. There's 90 degrees, and there's 180 degrees. To me, that image looks kind of about the same. I'd like you to stay there for a second. Think about that for a second. Think about what you see, and then I'm going to rotate faster this time. There's what it is right there, right there. What I learned from this is that I'm rotating my paper 90 degrees and then 180 degrees, and I see the exact same image. Since I see the exact same image, there's no need to have any other moves to make this happen. So what type of move takes figure A to figure B? I see that it's a rotation of 180 degrees around center point. Oh my goodness, it's not named. So let's name it. You pick whatever letter you want. I'm going to call it letter Q. And we're done. Your homework tonight is to basically do what you did last night, is to explain how something how a image rotates or reflects. But in this case, we're going to do a card sort where we find out which pair of cards show the shape and its image after rotation. So number one, it looks like a shoe. I need to be looking for the one that looks like a shoe. I see that this one is correlating. Is this one a rotation? I see that this one matches with this one. Is it a rotation? I see that 2 matches with 6. Is it a rotation? And I have to decide which of these 3 pairs of cards are rotations, and I have to decide which of these 3 pairs of cards shows a shape and its image after reflection. So I have to make sure I pair those up and look at those things correctly. The last thing that I need to do with it, or excuse me, the next thing I need to do with this, problem 2, is I need to be able to describe how that shape moves from each of its position to the next frame. In this one, I'm looking for precise language now, where you're talking about rotating a certain number of degrees and a direction. So we call that with magnitude and direction. The magnitude is the measurement of the degrees. The direction is clockwise or counterclockwise. The translations are up, down, left, or right. I shouldn't see any of your responses having sliding or moving up or down or whatever. I should only see the move being translate or rotate or reflect. Finally, number 3 relates directly back to our entry task. We need to determine what kind of angle measure would be best to match up with this figure. I have a little strategy for you that I would like to suggest, and that would be to take this figure right here, and we're going to slide it down directly. I'm going to use this line for reference. We're going to slide it down to where it's more matching here. I want it to be as close as I can to where it was, and now I have to make a decision. I have 6 different options to choose from, and it's saying select all the ways the rectangle could have been rotated. So I have to decide, is it 40 degrees clockwise or 40 degrees counterclockwise? Is it 90 degrees clockwise or counterclockwise, or 140 degrees counterclockwise? I need to know all of the ways this could have happened. I think that's easiest to see when I look at it closer to this figure. And then I can make some comparisons just like I did earlier with this with the protractor and with my work. Again, remember that you're estimating, so it doesn't have to be precise. And I can look at some things. I can ignore these other lines over here and think, wow, what kind of angle is made here? And then after that, I see another spot. I see just a little tiny one right here, so maybe I need to measure that one right there. While this is on your screen, you hopefully can draw that on there, or make a quick sketch of it on your notebook, and then use that to determine the measures of these other degrees. I hope you're doing great with this. Please, as always, email me if you have questions. I am not able to get back to you necessarily right away during the normal school day because I'm teaching my classes, but I love to get your information back to me. or your questions to me, and I will have them answered by the end of the day. So it's usually going to be after school. But please keep asking your questions. You're doing a great job. Don't give up. You guys are doing great. Remember to have a great a great day at school. And when you get home today, do something nice for your mom or dad. Take care, you guys.